Okay, so this is our rotations video for my V-Day classes, since you all will, I'll be on a field trip, so hope you without me. So a rotation is our next of the transformations. So we talked about translations, reflections, and now we're on rotations. So a turn around a fixed point called the center of rotation. And the figure rotates at a specific angle and direction. So they'll have to give you a degree and tell you if it's going clockwise or counterclockwise. Though the figure can rotate around any fixed point, the most common center is the origin, which is 0, 0. Okay, so we have some ways we can do rotations. There's a couple different ways, and so it would be one of the most complicated ones, but we're going to introduce it with the rules. The other ones actually do have rules. I thought it would be good to figure out how to do it without the rules, and then we'll go through and practice with some rules. This one, also you can do it without the rules. We'll go ahead and write them, and I'll show you some other ways you can do it without doing the rule. But so basically somebody recognized a pattern every time they were doing these. And if you're rotating at 90 degrees clockwise, your original point xy will change order, so the y term will come first, and the y coordinate will change signs. So what this means is, if you have, let's say, 1, 4, then the 4 would be the new transform point, but it would be negative now, so negative 4 and 1. So you switch these places and you change the sign of whatever this was. If it was already negative, then it becomes positive when you switch it over. If you have the original point and you rotate it 180 degrees, then it's going to change both signs but not the order. And then lastly, if you have the original x and y coordinate and you rotate it 270 degrees, it's going to change this order and the sign of the x. So original point, no change, is xy. 90 degree change counterclockwise is yx, changes order, but you change the sign at the first. Then you change the order back, but change both signs, and then you change it one more time so that y and x are flip-flopped and only the back signs change. So, so we'll try some of these with the rule, and we'll try it with some different other ways too. So first we want to go ahead and graph the points. So I will give you a second to do that. I have a blank sheet of paper here. I'll go ahead and plot this at 2, 7. Okay, 2, 7 is A, 6, 5 is B, 4, 1 is C. I don't know what I do with my, Okay, so this is our original triangle. Then what we want to do is rotate this 90 degrees counterclockwise. So one way that you can do this, and then write the answers pretty quickly, I probably shouldn't have labeled it if I do this way, but is to actually rotate your paper. So the clock, if you look up at the clock, the red hand is going clockwise, so it's turning this way. So counterclockwise obviously would be doing the opposite. So we want to go 90 degrees counterclockwise, so we take our paper, which has got 90 degree angles on it, and we just rotate it so that the vertical side is now going to be the horizontal side. So I take it and turn it 90 degrees. So 90 degrees counterclockwise. So I turned it one time to the left. So now my new C coordinates, I am ignoring these because now these are negative. These are still positive. These will be positive because this is the positive x. So if you ignore what I've written here, it's negative 1, 4 is the coordinate for C prime. So I'm going to write the answers. So negative 1, 4, negative 5, 6, and negative 7, 2 would be my 3 answers. And I'm going to write those right there, and then I'll show you with the rule how that works. So A was negative 7, 2, C was negative 1, 4, and B was negative 5, 6. Okay, so that's one option to flip your paper. So if I plot those points, I can see if that actually looks like a rotation or not. So after I've written the points down, I can plot them, negative 7, 2. I don't have a great memory, so negative 6, but I have to look at it every single time. And then negative 1, 4. Okay, so C. Alright. So that looks like a 90-degree rotation. I would expect that if it was in the first quadrant, the full triangle, when you turn it 90 degrees, it would be in the quadrant right next to it. And that it would change its orientation. A would no longer be the top point because I'm turning it around here. So the third option sorry, I had to go grab the sheet of trace paper from my closet to show you after we got the rules, is to use trace paper. So this paper is just see-through paper. You would start off by plotting your points. You still have to plot the points for the initial to do the trace paper. And then what you want to do is you want to trace the points, A, B, and C, and label them. So you don't have to trace the triangle, just the points, and label them A, B, C. You also want to trace the cross, or the plus sign, for the origin, because that's where you need to anchor your turn. If you don't put this there, then it's going to turn 90. You won't necessarily know when it's turned 90 degrees. But because the axes are all 90 degrees away, if you anchor the center of your pencil there, and then turn this 90 degrees counterclockwise, you'll see that those points fall on our new A, B, and C prime points. So another way to do it is, if I hadn't had this point, I'd still get the answer. I would just need to take this and turn it so that this part of the plus sign now is on this level. So I turn it one turn, and it lines back up to another plus. Okay, and that'll tell me my coordinates for C, B, and A prime, which are the ones underneath the paper that you can't see, but I already wrote them in there. Okay, and then the third way was the formulas, so using these formulas. So I'm going to do number 1 off to the side here using the formulas. So if A is originally 2, 7, and we're using the 90-degree counterclockwise formula, so we're using the negative yx formula. When we change it, transform it, we're going to put the y coordinate first because it's xy right now. So we're going to put the y coordinate, which was 7, first, but the opposite sign, so negative 7, and then the x coordinate will be written second, and that's what we got. B, 6, 5. We're going to change it to y coordinate opposite sign and x coordinate second. And C, 4, 1, y coordinate opposite sign and C coordinate second. So those are the answers that we got. So the 3 different ways to do these problems. You can probably do some in each different way, I would suggest, and see which one you like the best. So again, I'll just go back through the ways real quickly, and if you like a particular way, just go back through. So the first way was to graph the points for A, B, and C, and then just physically turn your paper. So we'll do number 2 together too, and I'll just show you what that looks like. So you can physically turn your paper and get the new coordinates. The second way is to use some trace paper, which is provided in the back of the classroom in a folder, one of those color folders, or some trace paper. So you would copy the triangle corners, and then anchor your pencil or your finger at the origin and turn it once, so that you know where you've turned when you turned it fully 90 degrees. That's why this plus sign is important. If I didn't have the plus sign here, I could be all out here like, oh, I don't know where A, B, and C are. But the plus sign helps me know I gotta keep that plus sign in the middle. So that's where A, B, and C are. And then the third way is to use the rules. So a bunch of different options depending on, yeah, you get some freedom in this unit. Okay, so number 2, I'll do, like I said, all 3 different ways. So I'll start off with the rule. The rule for the 180 is really nice because you just change the signs. So for 180, if you look at it, x and y, you change the sign of x and change the sign of y, but you keep them in the same order. So without even having to do anything, I'm going to change the sign for... Okay, so if I just do the rule, xy comes to negative xy. So I'm going just show it on a sheet of paper here to the side. And now I'm going to move the paper. So it's going to be P was originally 2,6, Q is 6,5, R is 5,1, S is 1,2. So these are X and Y coordinates. And the rule for 180 is you change it to negative X, negative Y. Doesn't mean it becomes a negative. It means it's changing signs from whatever it initially was. So in this case, because they were all positive, it will change to all negatives. But if there were some negatives in here, when you change it, then they would become positives. So this is going to be negative 2, negative 6, negative 6, negative 5, negative 5, negative 1, negative 1, negative 2. Okay, so I just changed all of the signs. And those would be my answers I can write in the bottom. And then I'll do it the other two ways as well, so you can just make sure that you're good on all of that. So this is P was negative 2, negative 6, Q, negative 6, negative 5, R, negative 5, negative 1, and S, negative 1, 2, negative 2. Okay. So if I plot these and do the same problem but with the turning of the paper, I can figure out my answers and just check to make sure I did this correctly. So this one is, so I'm going to rewrite the coordinates so you can pause it and do this on yours. Okay, so I have all the points plotted, and if I want to connect them, you can graph this right on the paper that I gave you. It's just hard for me to see it, so I don't do it that way. I'm going to do it on a larger graph, but there's nothing wrong with the paper. It's just small for my eyes. Okay, so this is my original figure, and I want to rotate it this time 180 degrees. So how many times do you think that means that I should turn the paper for 180 degrees? If this is a right angle, perpendicular lines make 90. Okay, 2 is how many times I should turn it, so twice. So if I turn it once, and it doesn't matter for 180 which way you turn it, because you'll be halfway, so you can go clockwise or counterclockwise, so that's why there's no direction. So if I turn it once, I'm at a 90 degree counterclockwise, and I turn it twice, then I'm at 180. So now I've identified these coordinates. So this is negative 1, negative 2, which I got for S. And then negative 5, negative 1 is R, negative 6, negative 5 for Q, and negative 2, negative 6 for P. So again, I'm not considering these numbers, I'm looking to see it's in the negative quadrant. So I'm going over, negative, left, and then negative down. Okay, so that's one option. That checked, and then that was all right. And now I'm going to use my trace paper, picking a new spot, just drawing in the points and then labeling them, and turning the paper twice. So again, 180 means twice, so that's a 90 degree turn, that's 180 degrees, and again I get those same answers I just got when I turned my paper. So negative 1, negative 2, negative 5, negative 1, negative 2, negative 6, and negative 6, negative 5. And then you just want to graph those so you can see that what it looks like. It's good for you to see what these rotations look like, so you can tell what type of transformation occurred. Oh, let me do it in a different color. When you just are given the two types, the two figures. Negative 5, negative 1, negative 1, negative 2, negative 6, negative 5. Okay, so that's what our 180 degree rotation looks like. Slightly different than a reflection, because the reflection would be the same distance away, so the S would be more up here. So it's basically turned twice. Okay. So a bunch of practice problems for you to do whichever method you like, or to try a couple different methods. That's probably what I would recommend, and see which one you like best. Sometimes some of them are more convenient than others. For the 180, it might be the best to use the rule if you memorize it, but these rules you can only use if you memorize it. Just like the distance formula, it's easy to plug into, but you have to know what it is. They don't give it to you on the formula sheet. So easy isn't always going to work if you don't have things memorized. Okay, then there's 2 pages of practice for that. And then we're rotating around, the second one we're rotating around other points besides the origin. So the notes are already written here for you. So a figure can be rotated around any fixed point. In the example to the right, triangle ABC is rotated around, rotated 90 degrees counterclockwise about P. So basically what they're saying is that this point, and I'm going to erase some of these so that it doesn't get like overwhelming. So this point P, this triangle ABC, is going to be rotated around point P. So now I would essentially make my cross at the point I want to rotate it around. So now I want to do 90 degrees counterclockwise, so I'm just going to turn it one time. And they don't have the rotation right on here, it looks like. So let's try that again. Maybe C. And we should be able to turn it 90 degrees. So 90 degrees once. Okay, so sorry, I had the point label, so it's ABC, and then I put my anchor at P and turn 90 degrees, so it lands on ABC. So that's a quick way to do it. If you like the paper way, on the EOC you won't be able to use the paper. You actually can do it, but it's harder to see through because they give you that yellow paper. But you actually can do it this way. It does work against the computer screen. But you want to anchor your pencil at point P. Basically that's where you put your cross and you can turn it. So it's real quick if you do it that way. If not, if you did it the rule way, this one you won't be able to just turn your paper because you would need to relabel these if you did that. So if you wanted to turn your paper, you would have to say like, okay, this is coordinate 1, 2, 3, and then when you turned it, then this would be. So the turn the paper part isn't the best for the fixed points. But we can use vectors, so we're going to back to vectors like we did in translations. So the example here is going to outline the process. So you would start off graphing these points. And looking for a clean sheet. Okay, this one's clean. Okay, so for this example, okay, I'm going to get these points graphed really quickly and labeled. Okay, so 4, 7, way up here, 8, 5, and 6, 3. So those are original points, and we want to rotate them around point P. So P is at 1, 2. This is all coming from your sheet. So that's our center of rotation. And we want to rotate it 90 degrees counterclockwise. So what we're going to do with the vectors is use the rule. So if we do the vectors for P to X, P to Y, and P to Z, this is the steps, so I'm supposed to be going through these steps with you. So the steps again would be to graph it in the center of rotation. So we did step 1. Step 2 is to write the vectors formed from the center of rotation to each vertex. So I'm writing the vector formed from P to X. So my vector was coming like this, like we did in the translations unit. My vector from P to Y, and my vector from P to Z. All back to that translation, so it's good practice for translations for this. So P to X, if I wrote it in vector form, it's going to go over 1, 2, 3 units, and then up 1, 2, 3, 4, 5. So 3, 5. Go ahead and pause it and try to find the vectors of PY and PZ. 1, 2, 3, 4, 5, 6, 7, 5, 1. Okay, so I went ahead and did all 3 of them. And now we want to use the rule for y equals, or for counterclockwise 90. So the rule for counterclockwise 90 is you take the x and y, and you change the order and the sign of the y. So what we're going to do is we're going to take the 5 and make it negative, put it in the front, the 3 and make it negative and put it in the front, and the second one, and then the negative 1, make it negative, put it in the front. So these are the new vectors from P. So from P, I'm going to go, okay, so that's step. So write the vectors in the form, we did that. Use the rotation rules, so we used the 90 degrees counterclockwise rotation rule, which was this. So starting with the original points x, y, we used this rule. And now we're going to use the vectors from P to create the new triangle. So negative 1, 2, 3, 4, 5, and then 1, 2, 3. So this is going to be x prime. Negative 3, 7. 7 is going to be y prime. And negative 1, so starting at P going over 1, and then 1, 2, 3, 4, 5. Okay, so that would be my, that would be my new, those would be my new coordinates. I'm transforming this around P, rotating 90 degrees. Okay, so if that wasn't clear, hopefully it was clear with your peers, or maybe you can go back through and watch whatever step. Thank you. You too. Yes, please. Okay, so if I just check this, again, I have X, Y, and Z, and P here. I would make my cross at P, because that's the center of rotation, and I turn my paper 90 degrees. And it lands on it, so I know I did it correctly. So you can either use the vectors of the paper for this one. If you were to do the coordinates to turn your paper, you would have to make this your new XY axis, so that when you turn your paper around P 90 degrees, then this is the XY axis. But these are the points that you would identify from these are the vectors you would identify. So it's negative 1, 5 would be the vector, or the new change, but it's not the actual answer. So it's kind of confusing to do the flip on this one. So negative 1, 5 is how far away Z is from the original point. So you have to turn it back and do like negative 1, 5. So it's kind of a lot of work to flip the paper that way. I think because these aren't going to give you the actual coordinates. Yeah. Okay. Actually, I might have time to do one more just so you can see. Let's see. Oh, I wanted to talk about what clockwise means. So if you get something that's clockwise, just remember that your clockwise turns are the opposite of the counterclockwise. So if this is 90 degrees counterclockwise, then that means it's also 270 degrees clockwise. Okay. So if you look at the clock and you're traveling from 12 to 3, you go 90 degrees clockwise. But if you wanted to go to 12 to 3 the long way, then you would have 3 90-degree turns, so 270 degrees counterclockwise. So they're the reverse of each other. The 181 is nice. It's the exact same for clockwise and counterclockwise. And then the 90 degrees is the 270. So if you get a clockwise one, just look at the opposite rule for 90 that you would look at. So if it's a 90 degrees 90 degrees clockwise, you would look at the 270 rule for counterclockwise. Actually, I'm going to end it there. So I think that was pretty clear. If not, ask your classmates around you. I think probably somebody would have been able to pick it up and can explain it. And then I'll be back next week. But we'll spend most of the time on dilations. All right. Have a great weekend.